triangle congruent shortcuts. There are 7 of them that we're going to talk about, 5 of which work. The side-side-side congruence theorem, we abbreviate it as side-side-side. Let's try that again. And that basically says if one pair of sides are congruent, a second pair of sides are congruent, and a third pair of sides are congruent, then you could possibly have triangle congruence here, which we will, in fact, have. This just means that there are 3 pairs of congruent sides. Angle, 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 abbreviated AAA, says if you have 3 pairs of congruent corresponding angles, then that might be a way to prove triangles congruent. So these are 3 pairs of congruent angles. Angle, side, angle. Notice how the side is in between the 2 angles. The abbreviation is ASA, which means if you choose any 2 pairs of angles, marking them, and you mark them congruent, then the side must be in between those 2 angles marked congruent. That's the only way to show an ASA. When you want to show an angle, side, angle, which we would abbreviate as AAS, sometimes people will actually write it as SAA. It's the same thing, AAS, SAA. And you talk about those same 2 corresponding angles. Then the fact that the side is not in between the 2 letters that are marked A, the side's not in between the 2 angles, the side that you choose to be congruent cannot be in between those 2 angles. You have a choice of that left side, or you could choose the right side. It won't matter which side you choose, it's just that when you're dealing with an angle, angle, side, the side cannot be in between the angles. So up here, 2 congruent angles and the side between them, where here you have 2 congruent angles and a side not in between them. The next 3 are side angle side, side side angle, and hypotenuse leg. Side angle side is abbreviated as such, and that means you've got 2 pairs of corresponding congruent sides. I will do these guys. And then the angle has to be in between them, which means it could only be that particular angle. So these are going to be 2 congruent sides and the angle in between. I'm not sure why I put a dot there. Side side angle, SSA. This becomes the same 2 sides, but now the angle is not in between them. So you do have 2 choices. You can choose either the angles at the top, or you could choose the angles on the side. Doesn't matter which angles you choose. I'm going to go for the angles over here on the side, and that would show you SSA. So that's going to be 2 congruent sides and and an angle not in between. Hypotenuse leg is HL, and the fact that they're talking about the hypotenuse, you must have a right triangle. So let's make this the right angle. The hypotenuse is always going to be the side opposite the right angle, and there's 2 legs to choose from, a smaller and a larger. I'm going to go for the smaller for no particular reason. This looks like it would be an SSA problem, but it's not because you're in a right triangle. And in a right triangle, if a hypotenuse and a leg are congruent, the other leg must be congruent. So these are the 7 ways in which you can try to prove triangles congruent. We're telling you that 5 of them will always work and 2 may not necessarily work. So the 5 that work always are side, 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 angle, side, angle, 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 side, which you know could also be written as side, angle, angle, side, angle, side, and hypotenuse leg. The shortcuts that don't work are angle, 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 and SSA. SSA spelled backwards spells a word that is bad, and sometimes people call this the donkey theorem. Okay. AAA is very easy to show you why it doesn't work, and AAA doesn't work because of this reason. If we have an equal angular triangle, so we know that these angles are all the same measure, and we have this equal angular triangle, all of these guys are 60 degrees, it's very clear that these triangles are not congruent. So these are not congruent. They could be congruent if we actually made them the same size, but in this case they're not. So this is why we're saying that we can't use this as a shortcut. The reason why you can't use SSA or the donkey theorem would be a reason like this. If we happen to have a triangle in which you know that these two sides are congruent, very similar to like an isosceles triangle, and you know that these angles then have to be congruent, I could draw a third side. Let me just label this real fast, A, B, C. I could draw a third side coming from C, maybe like this, which I'm going to call D. And this side right now is a reflexive side. Whoopsie. D. So this side is reflexive. And it should be pretty clear that triangle ACD is not congruent to triangle BCD. It's clear visually, but you do have two sides congruent and an angle congruent. So these two triangles, again, this guy right here, which has two congruent sides and an angle that's not in between, and this triangle right here, which also has two congruent sides and an angle not between. That doesn't work. Alrighty. So in order to show that triangles are congruent, what you need to be able to do is show that there's at least 3 pairs of congruent markings on your picture. You have to state the congruent triangles. You need to state the congruence theorem. If for some reason congruence cannot be determined, then you're going to write CBD. And you're going to state the reason why. Usually the reasons why is going to be because of SSA, because of AAA, or because the parts don't match up or correspond. So these are informal proofs that we'll start actually doing them in more formal proofs. Determine whether each pairs of triangles can be proven congruent. If so, write an appropriate congruence statement and name the congruence theorem that supports it. If congruence cannot be determined, CBD, state as such and state why. So number 1, do we have 3 pairs of congruent markings in our drawing? And we do. We've got these angles here, and these angles here. So right now all that we're shown is AAA, and we know that AAA cannot be determined. So we cannot determine congruence of these triangles by AAA. If you look at this next triangle, you also have 3 pairs marked congruent. That to that, that to that, and the side to the side. So we've got 3 pairs of congruent markings, and we've got 2 angles in the side, but it happens to be an ASA setup. So we know these triangles are congruent, and they're congruent by angle side angle. So now all we have to do is name the 2 triangles. So if we decided to call the triangle on the left FDR, then the only name the triangle on the right can be, we've got to follow the same order. FDR, yellow, blue, green, is going to be WXY, going from yellow down through blue over to green. Next triangle. These are overlapping or intersecting lines. We've got these 2 sides that are marked congruent, and we've got these 2 sides that are marked congruent. Nothing else is marked congruent. So then you have to use what you've learned in the past and say, well, you know what? I know that these angles at N are congruent, and I know that because vertical angles are always congruent. So now we have 3 pairs of congruent markings, and it's showing you a side angle side triangle. Side angle side works. So for this particular problem, if we call the triangle on the left LMN, then the triangle on the right has to be called PON. Whoopsie, triangle. There's many ways to name the triangles, but if the letters don't match up, your answers will not be correct. Okay. These guys, number 4. We also have 2 pairs of triangles marked, or 2 pairs of angles marked congruent. We've got a triangle here up top, but then we also have this triangle here on the bottom. Notice how these triangles share this side, FH. This is that reflexive property. So you now do have triangles congruent, and it's by the 2 angles in the side, but it's an angle-side angle because the side's in between. We could call the top triangle FGH, and then the bottom triangle, if we make the parts match up, then you're going to have FGH is congruent to triangle FDH. On 5, you do have 1 pair of congruent sides, but you also have these markings here. Those carets mean the lines are parallel. So we know by those carets that TR is parallel to SQ. And parallel lines give you alternate interior angles that are congruent. You happen to have vertical angles here as well, so you got to pick and choose what you want to work with. Well, I do know that if I've got TR parallel to SQ, that one of the pairs of alternate interior angles are these, angle R and angle S. The other pair of AIAs are at Q and T. That's enough to tell you that you have congruent triangles, and I'm going to name them on the top from T to R to P is congruent as Q to S to P, and that's going to be because I've got angle, angle, side. There is no reason why you could not have marked vertical angles as well. And then maybe you had those angles not congruent by AAS. Maybe you had them congruent by ASA. Again, it doesn't really matter. Just understand that when you have all 3 angles marked, because you have a side, then you can prove triangles congruent here. Last one. Only 2 pairs of things are marked. This side and then this angle and this angle. So you have to go for another side or another angle. Well, I don't know for sure of any angles that are congruent, but I do know that this side right here, it would be LH, is reflexive. Whoopsie, I can't give it 2 slashes because it's already a line with 2 slashes. So then I do have triangles that are congruent. Oh, actually, you don't have triangles that are congruent because what do we have here? We've got 2 sides at an angle. And this is going to be that donkey theorem, the one that you can't do. We don't know that the angles at H are right. So this one right here is going to be can't be determined because you can't use, or I guess I could put by, not no, by SSA. And that's it. So in the homework, you need to make sure that you have those 3 pairs of congruent markings. You state the congruence theorems as well as name the congruent triangles. Good luck.